What's up, everybody? Welcome back to 8th grade science. Today, we are taking a step back and reviewing the 3 TEKS that we just took a mastery quiz on. There were 8.5a talked about the parts of the atom. And if you're watching this video, that means you are working on 8.5a. You are trying to better understand the 3 parts of the atom: their charge, their mass, and their location. Okay? So there's 3 things that matter. I want you to write it right up here with me. I want you to write the word charge. Beneath it, write the word mass. Beneath that, write the word location. Those are the 3 things that are super important for 8.5a, which you're reviewing, okay? We're going to go over some basic vocabulary. Then we're going to do some stuff on this diagram, and then we're going to answer some questions on the backside. There are some terms at the bottom of your page we do not need to know. We're not going to fill out, but they're just a part of this graphic organizer, which is really good. Okay, so we're going to start right up here with some cloud. Remember, there's only one cloud in the atom. The other part is the nucleus, but the cloud is named after what's in it, the electron. Please write electron with me. The electron cloud is the space outside, and I want you to underline outside, the space outside the nucleus. The nucleus is the center of the peanut M&M. It's that peanut. That is the nucleus. The cloud is the chocolate that surrounds it, okay? Next up, I gotta tell you what is inside of the electron cloud. This one's obvious. It is electrons. It's in the name. If you know the name, you know what's inside of it. Then what's important here are the charge and mass. Remember I said you need to know charge, mass, location. Location is the cloud. The charge is -1. Electrons are negative. Sometimes, and I want you to write this here, I'll write electron as that. E negative, electrons are negative. Relative mass. Remember we talked about the neutron and the proton weigh something, but the electron weighs nothing. It has 0 mass, okay? Electron is in the E cloud. Its charge is -1. Its mass is a 0. All right? We're going to scoot down. We have a diagram. What this is pointing to, the area we just filled out, all these electrons floating around in this space. This is all inside the cloud. All right? The center has a different name. Y'all should be able to predict this. I'm going to write it. Nucleus is the center. The nucleus of the cell from last year was the brain of the cell. The nucleus, or the center of the atom this time, is where protons and neutrons are stored. I want you to come right up here and write proton and point towards one of these plus things. They'll always show you whether it's a positive, or if it's neutral or a neutron, it won't have any charge. So for instance, this right here is a neutron. Okay, and they're both clumped in the middle. They're both inside the nucleus. The nucleus contains 2 things. First, the proton. Second, the neutron. And after this little colon by nucleus, write center of mass for atom. Why do I say that? Why do I say it's the center of mass for the atom? Well, the reason I say that is there are 2 things that have mass. I'm going to put them both right here. The proton and the neutron have a mass of 1. Everything that has a mass is in the center, or in the nucleus. Everything that has no mass, the electron, is in the cloud. So the nucleus is the center of mass. The charge on the proton, remember P means positive. It's a +1 charge. The charge on the neutron, we see the root word neutral in there. It means you don't take a side in a fight. In this case, that means there is no charge on the neutron. Okay? I want you to flip your page with me. Flip it over. We're going to define a few more of these words. Just the top 6. We are not going to do electromagnetic force through isotope, so you can just do this with your pen or pencil and get rid of it. We're not doing that. The rest of it we will. Really quick definitions right with me. The atom is the smallest particle of an element. So you can have atoms of carbon, abbreviated with a C, atoms of oxygen, abbreviated with an O, atoms of fluorine, abbreviated with an F. That's all right, but then watch this. I'm going to make myself a little box. I want you to do it too. You cannot say that this is an atom of CO2. That's called a compound. We're going to get into that later this week, early next week. That's a compound, okay? Atoms are the smallest particle of a single element. Then an element is a pure substance. So it's the smallest you can get. CO2 or carbon dioxide, something we breathe out right here, that's made up of two elements, carbon and oxygen. That's a little preview of next week. Don't worry about that right now. The atomic mass, oh, I'm sorry, I skipped one. The atomic number. This tells us number of protons, number of electrons, and it tells us atomic identity. So the number of protons makes a certain element what it is. That determines atomic identity. It's like your name kind of determines your identity, who you are. The number of protons determines the atom's identity. All right. It's also equal to the number of protons and electrons. Atomic mass, we're just going to write this. Am equals P plus NO. I've written that 100 times. I'll write it 100 more. Atomic mass is equal to protons plus neutrons. Now, how do you determine the number of protons in an atom? This one's simple. Look at P table. That stands for periodic table. I'm going to draw a quick little entry pretending we have periodic table. Do this with me. The atom hydrogen has a little symbol right there. The upper left, it normally has something like that. It has a decimal number at the bottom. The atomic number, I want you to circle it and point to it, is this 1, and put an arrow from it to this question. That is your number of protons in the atom. Okay? I'm actually going to do a new example. I'm going to redraw it so you can keep your exact same stuff, and I want you to draw another one with me. So find space on your graphic organizer for this one too, because we're going to use this one for the next example. You're going to do oxygen 8, and it has an atomic mass of 15.9. So that's oxygen, atomic number of 8. See, I still have the atomic number there, an atomic mass of 15.9. I need that for this, because we need to figure out the number of neutrons in an atom. We take our atomic mass, which we know is 15.9. It's equal to the number of protons, which is 8, plus the number of neutrons. Something y'all should have caught me on. I made a mistake. We never write 15.9. What do we always do? Cross out that decimal. 15 equals 8 plus neutrons. Then I'm going to subtract 8 from both sides. 15 minus 8 is 7. 8 minus 8 is 0. That just leaves me with the number of neutrons. So that is how you solve number of neutrons. Write this with me, and we're going to box it in. Number of neutrons is equal to atomic mass minus protons. All right? That's all there is to it. Now you are going to do a worksheet with something called Bohr placemats. Bohr placemats are Bohr models slipped inside slip covers, and you are going to work with little bingo chips to build atoms based on their periodic table entry. And then you're going to check them against the key. You're going to be physically building them with your hands. Be thinking as you move through that station, what am I doing with protons? What am I doing with neutrons? What am I doing with electrons? The 3 things you need to know about them are right here. Their charge, their mass, their location. Great job. You can move on to the Bohr placemats activity.